first question. Okay, which question?
1K.
1K. Where did I put? Yeah. Insert. Picture. 14.1. Hi. Oh, sorry. Is this the one? 1K, huh?
Yeah.
Okay, a quick one only. This is the IG question. So K, right? E to the power x minus e to the power negative x divided by 2. E to the power of x minus e to the power of negative x divided by 2. We have to differentiate this one. Okay? Right. So we have, you can take out the 2. Or you separate it. Yeah, we separate it. So d by dx, e to the power x over 2 minus e to the power of negative x over 2. So we treat it as fx plus or minus gx. So when you differentiate this, it will be f prime x plus minus g prime x. Okay? This one you all don't have to do anything. This one is IG question. Okay? Therefore, when we differentiate this one, how do you differentiate ex? It will always be ex itself. And x is actually 1. So copy everything. And you try to differentiate the x, which is 1. So it's still itself. And over here, it is e to the power negative x over 2. And followed by differentiate the function x, that is negative 1. And therefore, you have e to the power x over 2 plus e to the power negative x over 2. So your final answer will be e to the power x plus e to the power negative x over 2. That's it. Is that okay? So your question is?
This, right? Can you separate it like to e power x plus e power negative x times 1 over 2?
Where do you do? Here.
Yeah.
The 2. Yeah, you can do you can put the 2 outside, yes.
Then wouldn't that make the 1 over 2?
The question is minus leh. The question is minus. The k, 1k is minus. You copy wrongly. It's minus. You copy plus. That's why you don't get the answer.
Wouldn't that still be the same?
It's not the same, because when you differentiate the negative x, right, it become negative 1. Negative 1 times with the negative here become positive. So your answer is positive, but your answer, if you do correctly, the answer is positive. But you copy wrongly, your answer will be negative. That's why you found this, and yet it's not the same answer as the answer given, correct?
I'll try again.
Okay. So, alright, any question regarding to the differentiation application question? Did y'all try all the question in the book? We just handpick a few that you cannot do.
Teacher, practice summative.
Okay.
Practice 1,
Yes.
question number 2.
Question number 2. Okay. Oh, this one. Okay, in exam won't come out this question, okay? In the exam won't come out this question. Why is this for? It's for me to drill your brain, that's all. Okay, in the diagram, in the answer space, we got to sketch the graph y equals to fx that satisfy the following condition. Now, the point A, B, C lie on the curve y. So we have the curve y with the point A, B, C. Now the f prime x point A, that means the differentiation at point B and the differentiation at point C is 0. So when the differentiation means what? The gradient of tangent equals to 0. Is that okay? Which means you will have like this, like this, like this. So your curve could be, you have 3 turning point, you know? You have 3 turning point. Okay? Now, and then over here, when you continue to do second order of derivative, you notice that at point B, okay, the point A is, which one? This is less than this. This is smallest lah. This is smallest. Okay, and then this is the biggest. How do I know big or small? Probably will be positive. This will be negative, and this one will be in between 0. Because there is the only 2 possibility. When I have my gradient of tangent is 0, I want to test the nature of the point, I will do the second order of derivative. So over here, the question actually tests you whether you understand what does it mean by first order of differentiation and second order of differentiation. So first order of differentiation, finding MT, the gradient of tangent. Second order of differentiation is to test the nature of the point. The nature of the point, which means it's either maximum, minimum. And we have one odd one. When it is 0, you can't tell the conclusion. This is for inflection point. Inflection point, okay? Right? And next, for B1 and B2, what is B1, B2? Oh, B1 at point B. So I had, let's say this is the curve. I just simply put B is here. I test the B1 and I test the point B1. Okay. It means your x B1 and then test the nearest point B2, the x B2 lah. The point before and after. I noticed that they are the same. Same as in both could be negative or both could be positive, which means they will continue if it is positive, horizontal line, and then positive, so it will be an inflection point. If it is negative, because when at B your gradient of tangent is like this, then when you do the test the point before and after, they are of the same sign. So either both positive or both negative. This is point B, or both negative. Then isn't it, it's an inflection point? So confirm this one that it is an inflection point. B, inflection point. Okay? Now, therefore, we can sketch the graph. Now over here, C, the point C is the smallest. If this is 0, this is negative. So point C, when it is negative, set face, so the point C must be maximum. Okay, so over here, C is maximum, therefore smiling face, the A must be minimum. Wow, very messy. Can see or not? Can see, Okay, so now let's sketch. I have to sketch in such a way that the graph could be like this. Okay, so this will be my point C. This is my point B. My A is minimum what? Wait, is A minimum? Yes. This is my point A. You just sketch anywhere as long as I see this. Or you can sketch the other way around. You can sketch such that, like this. And then you have an inflection point, and then you go like that. So this is your point A. This is your point B, inflection point. And this is your point C. Okay, maximum point. So let's double check. When I do the gradient of tangent differentiation, first order differentiation, I will have my MT0. Okay? And then I do the second order of differentiation. I want to test the nature of the point. This one, you will have the double x greater than 0. This one will be double derivative less than 0. Less than 0 is like a negative lah, a negative sad face. This one a positive, it's like a positive, so smiling face. And the b is the one is 0. Your double derivative is 0, but when it is 0, we can't do any conclusion. We can only test the point before and after, and that is the reason over here. We're testing the point before and after. Okay, so that's how you do the sketch. Two answer, both acceptable, as long as A minimum, C maximum. Where you cross doesn't matter. You can cross here. Okay, also can, no issue, as long as I see A, B, and C, obviously. Okay, right. Okay, any question that you have tried? Any other question? No more. No more? Did y'all do or not? Huh? Did y'all do? Okay, let's try some more question. Okay, let's see this. This is a very easy question. Now, when your del y is this, find dy dx when x equals to 2. Actually, this question, whenever you see del y, you know that it's first principle. They already done for you. Find the del y for you. You just need to continue, that's all. Okay, so when del y equals to this, so we divide both sides with del x. Therefore, we will have del y by del x equals to 4x plus 2 del x plus 3. Okay, now, so we need to find dy dx. It will only be equals to dy dx when we set the limit that your del x approaches 0 onto your 4x plus 2 del x plus 3. So this one, when we substitute, it will become 0. We will get 4x plus 3. Now, when x equals to 2, the dy dx will equals to 4 times 2 plus 3, 11. That's it. Simple? Okay, find something also similar, yeah? Wow, too many keyboard. Too many keyboard already. I want something this one, 2 marks only. Given that y equals to 5 and dy dx equals to kx to the power of m, based on the formula for the first derivative, state the values of k and m. How? If your y equals to 5, how do you find dy dx? How do you find dy dx? When your y equals to 5, your dy dx is? Your dy dx is 0. How do you get 0? Do you still remember the formula? There's actually an x to the power 0 here. You bring down the 0, so you have 5x to the power 0 minus 1. And therefore, you will have 0 times 5x to the power of negative 1. Now you compare with k at x to the power of m. Compare, isn't it your k is 0 and your m is actually negative 1? That's it. Okay, so go back to basic. Go back to basic. Why is y equals to a constant is 0? It's because there's actually an x to the power 0 there. X to the power 0 there. So you bring down the 0, yeah. So you're left with 5x to the power negative 1. Okay? Done, huh? So let's look at number 4. Given the equation of the curve is 2x squared plus 7x minus 1. Find the coordinates of the point on the curve that has the gradient of 5. Let's just simply sketch. Whenever I see the gradient function, I will do this. I have my y equals to 2x squared plus 7x minus 1. I use this one to guide me what to do next. So I have the gradient of the curve. Find the coordinates of the point. So this one I don't know, x, y. This one I don't know, but I know that the gradient of the tangent at this point is 5. Hence, find the value of constant p such that this is the tangent to the curve. This whole thing is y equals to 5x plus p. Y equals to 5x plus p is the tangent to the curve. That means the equation of the tangent to this curve. So you must label correctly. So what can we do first? This golden triangle here, right? I do this one first. Come down to differentiate. So I know that my dy by dx equals to 5. So what is dy dx? It is 4x plus 7 equals to 5. Isn't it? I can find x now. So 4x equals to negative 2. X equals to negative half. So I found this one to be negative half. But I need to find the coordinates. What is the y value? This golden triangle, now you sub in here. Sub in here, Therefore, y equals to 2. Negative half squared plus 7 times negative half minus 1. So, are you okay with the flow? So with this one, it will actually guide you. First, you're going to need to do this. Has nothing to do with this one so far away. Don't use this one first. You should start with the differentiation. Immediately, you got this. Then, because this equals to 5, so that means if you know the x, you substitute, you should get 5. So you work the reverse. So now you got the x. This one, I already said these are golden triangle. There was either this substitute to this, or this substitute to gradient of tangent function to get the gradient. So now I substitute to the function to get my y. What's the y value? Negative 4. So the answer we found, right? Find the coordinates of the point. Therefore, the coordinates will be negative half and negative 4. Found this. Next, find the constant p such that this sub in lah. Because the gradient of the straight line passes through this point, and the straight line having this equation, therefore we shall substitute the point, substitute negative half, negative 4 into y equals to 5x plus p. Because they say hence, that means no need to use other way. Continue to what you have found and find this. So the continuation is basically substitution. Whenever you see y, you put negative 4. Whenever you see x, you put negative half plus p. So p equals to negative 4 minus 5 over 2, bring over plus 5 over 2. Okay, and then negative 3 over 2. So that is the p values. Okay, correct? So you have to try the question, yeah? Now, find some more question. Choose the one without the k-bar one. Too many k-bar already cannot. But everything also k-bar. Okay. Alright, this one. This one in your textbook also. Similar question. Given the equation of the curve y equals to 2x cubed plus x, by using the differentiation method, find in terms of p the approximate percentage increase in y when x increases from 2 by p%, where p is a small value. How do you do this? It's an approximate question. First of all, you have to identify this is an approximate question. When approximate question, which one do you need to apply? Del y, del x approximately equals to dy dx. So you must know which one to apply. So this is the one. Okay? So if this is the one, I have my y. So let's find dy dx first lah. Okay? If y equals to 2x cubed plus x, find me your dy dx. Okay, next I need to find the del x, because find the percentage increase in y when x increased from 2 by p%. So my x is 2. When it increased by p%, that means the del x is p over 100 times 2. Is that okay? Because it says increase by p%. So it will be 0.02p. So my del x is 0.02p. Because I know I need to find the del y, I must have del x. That's why you need to link with which application I should use. In that application, dy dx is a must, del x is a must. So you will know what to find. First of all, what is dy dx? Yeah, 6x squared plus 1. Plus 1, yeah? Yeah. Okay. Then what do we do next? So del y will approximately equivalent to dy dx times del x. And dy dx is 6x squared plus 1. 6x squared plus 1 with the original x. Don't forget, you have to substitute the original x into your dy dx. Okay, so that is 2, and then times with the whole thing, times with 0.02p. Okay, let's calculate. 25 times 0.02. 0.5. Right? 0.5p. Okay, this is not the answer yet. The increment is 0.5p, but we want the approximate percentage increase. If this is del y, then I need to find out what is the y value, because the percentage of del y will be del y over y times 100%. Don't forget this. Okay, already know the del y, which is 0.5p, but then what is y? So you should substitute the x equals to 2 into my y. Right, so del y is 0.5p. The y is, what is the y? 2x cubed plus x. 2x cubed plus x times 100%. What? 18? 16? 18? So 0.5p over 18 times 100%. Use calculator lah. .5 divided by 18, actually is 36. Alright, times 100. Wow, okay. Change to this improper fraction. I don't want to round off, yeah? So I will use (25 over 9). So therefore the answer is 25 over 9p%. That's it. 2 point something p%. In terms of p. In terms of p. Because we do not know what is p. So in terms of p. Is that okay? Find the increase. Yeah. So we got extra things here. The percentage of increase. This one apply what you have learned in primary school. Percentage of something. Yeah. Percentage of something. Okay. Any question? Okay. Alright. Let's look at the actual SPM question then. Not actual, the trial exam. Trial exam. What is this module? This is the module topical. I think include everything. Module topical form 4. The form 5 one. 4, still form 4. Do we have form 5 here? Ah, yes. Okay. Circular measure. You still have this file, right? Yeah. Go explore the question in the file, yeah? So chapter 1, chapter 2. Okay. Let's try the question here. Is this the first question? Yeah. Right. You do. 5 marks. 5 minutes. Okay.
I have a question.
Yes.
It says express y times the second derivative, right? I take the y as x times 5 minus x, or I just take the y? Yeah.
Of course, at the end of the day, will be in terms of x, lah.
All right.
In terms of x, okay? Okay. Right? Can find the answer? Can do?
B.
B. Okay. Right. Let's check. Okay. So for A, y equals to this. Now I would write like this: 5x minus x squared. I won't use the product rules. Why choose the trouble? Okay, just expand and do the fx and gx thing. Okay, now so we find dy dx and d2y by dx2 separately. Okay, so for part A, since y equals to 5x, what's that again? Minus x squared. Minus x squared. So dy dx will be 5 minus 2x. And d2y by dx2 will be negative 2. And now let's put this in y, d2y by dx2, and then plus dy dx squared. Dy dx squared and d2y by dx2 is two totally different things, yeah? Plus 15. Okay, we've got to write in the simplest term. So the y is 5x minus x squared. And then the d2y by dx2 is negative 2 plus 5 minus 2x squared plus 15. Just substitution. Open up the bracket. We have 2x squared minus 10x. Over here, we will have 25 minus 20x. And then plus 4x squared. In front is positive, so you can safely open up the bracket without any, no need to worry about, wait. Okay, no need to worry about the negative sign. Try to have some space in between. How come I cannot erase? Okay, try to have some space between number and number. Yeah, 25 minus 20x plus 4x squared, and then plus 15. Group the like term together. So we have 6x squared, and then minus 30x, plus 25 plus 15, we have plus 40. Is there any way that we can simplify it further? Because it's in the simplest form. Let's simplify it further. We take out the 2. So we have 3x squared minus 15x plus 20. I'm not sure whether should I just expand like this. 3x and x. 10 and 2. Yeah, 10 and 2. Negative. Double check. 3x squared. Negative 10, negative 2 is positive 20. The inner pair, negative 10x. The outer pair is 8. Not correct. Not correct. Double A. The other way around. Oh, cannot. Cannot. A. Oh, cannot erase. Hang. Wait, This one cannot. 4 and 5. 4 and 5 cannot. 4 and 5 cannot. Alright, 1 and 20. 2 and 10. 4 and 5. Only this 63 minus 15. 3 times 10. Oh, cannot. No way I can factorize. So no need. Just leave this as our final answer. Okay? We can also double check using the calculator. We assume that equals to 0, but this is not an equation, it's an expression only. If we assume that it is equals to 0, so we will have the degree 2. So we have 3, negative 15, and then 20. Cannot, because imaginary number. Alright, cannot. Cannot. Oh my goodness. Okay. Okay, the one is only A. Haven't come to B yet. Okay. So this one no need, Okay, the B. Hey, I open up too many things at the back. No. No what? Okay, the B. The area of a square with side x increases at the rate. So this is the rate question. So the rate question, you must know how to write d something by dt. Okay, the area of the square with x. X by x. So the area increase. So dA by dt equals to 3 cm squared per second. So find the rate of change of this side when the area is 9. Okay. So we need to find dx by dt when the area equals to 9. So let's find the things that you want to find. You split it into two parts and you chain together by the one given, dA. You see dA by dt I have? Now I just need to find A in terms of x. Now A is x squared. So dA by dx will be 2x. But what is the x value? We don't know. However, we do know that A equals to 9. So x squared will equals to 9. X will be 3. Which means when A equals to 9, x equals to 3. At the end of the day, we want x. So therefore, dx by dt will be dx over dA. Straight away we replace. Alamak, cannot erase. So dA by dx is 2x. Therefore, dx by dA will be 1 over 2x lah. Okay, I'll just continue from here. So over here will be 1 over 2x, whereby your x is 3. dt by dA is given 3. Simplified. So the answer is 0.5 because it is the side, the increase of side, cm per second. Okay, any question? Did you get this? Okay, Ken, Alani, all right? Yes, simple, yeah. Okay, next, this one. You have a curve with this function with the stationary point. You need to find the value of m. Now m is not gradient here, m is the x coordinate, so be careful of the symbol used, yeah. Hence, determine the nature of your stationary point. Okay, you do. 5 minutes or so. Actually, you should. I'm very scared when it gets stuck. Okay, 5 minutes. Okay, start now. Okay, done. Right, let's check the answer, yeah? Or maybe yours send, Eugene send your working to me. Let me check. I come to your, come check your working. Stuck somewhere. Okay, let's see. This one, okay? X equals 2. This is, right. Oh, maybe it's my fault. Sorry, I didn't see properly. Find the value of m. Okay? Find the value of m. A curve with gradient function has a stationary point of this. So find the value of m. I think it's my fault. A you cannot do. It's integration. Sorry, my fault. Can you? Yeah, cannot. Sorry, yeah. My fault. I didn't really check the answer. Okay, never mind. Sorry. This is integration. Put under differentiation, but it's actually integration. The chapter 3. Okay, this is integration. Why? Because the curve with the gradient function, okay, this is the one. The gradient function is x minus 27 x to the power negative 2, which means you do not know what is the curve, but you know that this is m3. So how do I use this when I have unknown here? I have sort of like known here and unknown here. So we have to go up, find the y first, then only we can substitute with the y value, then we can find m. So it's my fault here. This one should be an integration question. So skip, sorry, I've wasted your 5 minutes. Erase that one first. Let me check this one first. Given that this equals to this, find this. Okay. Given that this equals to this, find the first principle. And then it shows this and the straight line. Given that this is parallel to the tangent to the curve at this point, find the h. Okay, this one you can do. This one you can do. Do A and B first lah. Okay, 5 minutes. So this one should be okay, can do, right? Okay, number this one 3x. What are you trying to do? No. Okay, you forgot the product rules already? The product rules. This one we need to use the product rules, not just the chain rule, because you have x outside also. And this is fx. The moment you start reducing the power, you should write f prime x. Okay, this is the first one. Second one, dy dx using the first principle. Okay, alright, correct. Okay, correct. Okay, only the A, part A not correct. Can you see? Okay, this one. Stay V, U plus stay U to B. 6 to the front, and then 2. Okay. 6, 12. Then 2x power 6, power 5. 6x. Okay. Okay, correct. Stay V to U. Plus is a plus because it's a product rules. Product rules always plus. Okay, correct. Wait, this one. It's a limit then x plus del x. Don't substitute first because your limit is still here. The moment you substitute, this one no need to write anymore. Okay. Stay V. This one stay V. Do you differentiate this one? So it's 3. And then stay U. Do V. This one bring down. This one power 5 is 2. This one correct. Only this. This is your UV. Where's your UV? Okay, this is your U. This is your V. So stay V. Differentiate U. Differentiate U is 3. 3. So only this. Okay, this one correct. Then you factorize. Okay, where is this one? It's H. Okay, correct. Just need to continue. Okay. Right. Eugene and Yijing, where's yours? Okay.
Doing the last one.
Doing the last one, the B. No need to do C yet. A and B, I just want to check A and B.
Okay, okay.
this one, the bottom part. Okay, stay V to U. Hey, how come 36? Oh, why is it 36? Why is it 36 here? And then the power, you bring down one power, minus 1, so power 5. Okay, never mind. Okay, we do step by step. Okay, let me check. Okay, this is B. Stay V, do U, plus stay U, do V. Okay, then you factorize. Okay. Okay, as for this one, all right, correct. Now this one, some of you may forgot already. This is U, this is V. How do I know that I need to apply the product rules? When you have a function in X multiply another function in X, it's a product rules. If this is 2x plus 6 raised up to the power 6, then this one is not product rules. You can just bring this down and multiply. So you have 18, 2x plus 6 to the power 5, and then 2. Then you got 36. Okay? This is when it is the coefficient 3 in front. But this is not the case. I think you're confused here. That's how you got 36. Right? Now, actually, sorry, I cannot erase. Something is wrong with this part. Okay, never mind. Alright, so look at here. It's UV. So therefore, if you cannot do everything at one go, you should do like this. U is 3x, and then V is 2x plus 6 raised up to the power of 6. Step by step is okay. So du by dx is 3, and then dv by dx is bring down, do outside, do inside. The outside, reduce the power by 1, and followed by differentiate the inside, which is 2. So the inside, you do outside only, the inside unchanged. And therefore you will have 12, 2x plus 6 raised up to the power of 5. So now we're going to combine them, cross multiply to plus them, okay? So your dy by dx will be, now how do you write multiplication symbol? It's this stroke first, then this stroke, right? So we shall use this one, the first and the second. So it is 2x plus 6 raised up to the power of 6 of 3 plus the other one, 3x, and then times with 12, 2x plus 6 raised up to the power of 5. When we reach here, you got your first point. Next, you need to factorize. How do you factorize? Find the common things, step by step, okay? You have 2x plus 6 to the power 6, 2x plus 6 to the power 5. Choose the smallest one that's shared by both. And also you have the 3 here and the 3 here. So I can take out the 3, 2x plus 6 to the power of 5. So your first term, taken out the 3 already, taken out the power 5, left with power 1. So left with 2x plus 6. Then the second term, 2x plus 6 to the power 5 taken out. 3 also taken out. What is left behind is 12x. And therefore, our dy by dx equals to 2x plus 6 to the power of 5. And then this one is 14x plus 6. Now we can simplify further. Please try. So take out the 2. 2 times with the 3 in front, 6. 2x plus 6 raised up to the power of 5. 7x plus 3. 7x. Oh, I cannot erase. 7x plus 3. No choice. Okay, this will be your final answer. If you can simplify further, simplify. If you leave your answer 2x plus 6 to the power of 5, and then 42x plus 18, I think okay also. It's alright. Okay, let me shut this down first. I restart. Okay. Now your first principle, I looked through, okay. Right, the first principle, yeah. So y equals to why not responding? Wait first. Okay. So you all still have this, the 2024 trial paper, right? It's 24 or 25? 24. Go back and do, okay? I want you to try all the questions. I cannot try one by one here. I want to go to the next topic. Your exam until which topic? School exam? Not yet. Not yet. Okay, never mind. You see, hang again. Cannot do. Sorry. Ditakdirkan to continue the next one. You cannot continue here. So I checked your first principle. I think all of you okay, so no issue. Right, we go to the next part. That is integration. The one that we got stuck just now, right? It's actually the integration. So remember to do all this, the question, yeah, in the trial paper question. Okay, so that you have a feel like, oh, how does the question ask in the exam? So far differentiation, the 4 application, make sure you master it. It's very, very easy. Okay, so do try the question, right? And then I think it's not the, it's my computer suddenly slowed down. Okay, so let's go to integration. Integration is very short, very short. Unlike differentiation, we have 4 application. Different integration, we have 3 application only. Okay. Right. Now, so for integration, what is it about? Yeah, this is the overview. Let's just see the overview first. We have the indefinite integration and we have definite integration. We shall look at it in detail, yeah? So let's look at what is integration. Integration basically is the reverse process of differentiation. And do you still remember what is differentiation? It is multiply the term with the original index and then you subtract 1 from the original index, right? So you bring down the power to the front to multiply and then you minus 1 from the original power, right? So multiply the term with the power minus 1 from the original power. Therefore, the integration will be the other way around. Instead of subtract 1, you plus 1 first. Copy everything, plus 1 to the original index, and then times, right, become divide the whole term with the new index. Okay? Right, for example, like this one. So y, let's say y equals to, this is dy dx. dy dx equals to 12x cubed. Now, you want to, integration is the reverse process of differentiation, which means you bring the differentiation symbol over to the other side. Okay? Your differentiation, you bring over to the other side, it will become left with y, and that is exactly what we want. We want to find y. We want to find y. equals to the differentiation. When you go across the other side, reverse the function of differentiation, become integration. This is the symbol of integration. Integrate what? The 12x cubed. Okay, so integration very easy. Copy exactly the same, copy. Then you plus 1 to the power. You divide the whole thing with the new power. And then plus c. Why plus c? Because the constant after you differentiate is 0. So you won't see here, but there may be a constant at the back. So over here, the answer is 3x to the power 4 plus c. The c could be plus 5, plus 100, plus 10, doesn't matter. Because double check, always double check. When I differentiate this, I got back my 12x cubed. Then that is correct. Okay, one more time. See how I did? I copy exactly the same, and then what I did was I plus 1 to the original index, original power, and then I divide the whole term with the new power. Divide this with the new power. So that when you double check, you bring this down, you multiply, isn't it? You multiply the term with the original power here. 4 times 3 is 12x. So you take 4, multiply, copy exactly the same, but you minus 1. This one you multiply first, then you minus. The integration is you plus first, then you divide. Okay, that is the difference between the differentiation and integration. Okay. So now, since we understand that integration is the inverse of differentiation, so let's say the question gives you like this, yeah? When you differentiate 4x cubed minus 5 equals to 12x squared, now they want you to find the integration of 12x squared. They give you this, they want you to find that. No need to go and integrate yourself. Use whatever thing is given. Since they give us this, so we shall bring this to the other side. So we will have 4x cubed minus 5 equals to integration of the other side, 12x squared. Okay? So from the information, we change to integration first because we need integration. We need to solve integration question. So isn't it coincidentally or accidentally we found the answer already? Therefore, the integration of 12x squared dx is 4x cubed minus 5. That will be the answer. Because they give you this, they expect you to find the integration. Unlike the one that we use the formula ourselves, just now remember the formula? We copy everything, we plus 1 to the power, we divided the whole term with the new power, and then you have to add plus c at the back. So the answer will be 4x cubed plus c. If you answer like this, you don't have any marks. Then you may argue, it's the same one, 4x cubed. My plus c could be any number minus 5. Yeah, I know. But we are not testing whether you know how to integrate. We are testing you so that whether you know that integration is the inverse of differentiation. Otherwise, why do they give you this? They don't give you anything for nothing. They give you something because they want you to use that. So in this case, they expect you to understand the relationship between differentiation and integration. Since they give you this and need to find integration, try to change the differentiation into integration for information so that we can apply here. Your exact answer is this. So this part is not correct. Understand? Understand the way they ask question, why they ask like this, right? You may ask why they give us this one. I can also find this without using the front. You need it because without the front, your answer will be in terms of plus c, but actually it's minus 5. Okay, we look at one more example, yeah? Okay, you are given fx, 2 minus x over x. F prime x is this. So if fx is 2 minus x over x, and then f prime x equals to negative 2 over x squared. The f prime x, right, is actually f prime x, because we don't know how to read this, yeah? I mean, I don't know, I feel very confusing. I will write it as dy dx equals to negative 2 over x squared. So I want to find y. I shall bring this over. So my y equals to integrate of negative 2 over x squared dx. Okay? Or you need to remember this. If you don't want to write like this, can, no issue. The thing is, I want to find integration. My information must be, we must write it in terms of integration. So if I get rid of the prime here to the other side, I will get back the fx. The fx equals to negative 2 over x squared dx. I need you to write like this, okay? If this one you still feel very blur, then you go to this, okay? Your y equals to fx. So that means this thing, that means I have the information now. This whole thing is actually 2 minus x over x equals to integration of negative 2 over x squared dx. Now I need to answer the question, this one. Therefore, integration of 1 over x squared dx equals to, now what I have is negative 2 over x squared. So I try to put the negative 2 over x squared in this format. So I lack of negative 2. So I lack of negative 2, so I just put negative 2 over x squared dx. But there is no negative 2 here. Why suddenly you got a negative 2 there? Oh, I neutralize it with 1 over negative 2. Is that okay? So that your left hand side is the question that they ask. The right hand side is my adjustment. It's my adjustment so that I die also. I want to use this. Okay, I force this one in here, but I need to maintain the value. It must be positive 1 over x squared. So this line, are you okay? Ken? Alright. This is the one that you need to find. And based on the information that we have, I need to use this. So once I put it in, it's not equals to this. How do I equalize it? So I neutralize the negative 2 with 1 over negative 2. So that when you cancel off, you get back 1 over x squared. So now they are still equal. Still equal. The only thing is they don't look the same. Therefore, isn't it this whole thing is this? So now we put it in. Negative 1 over 2 times with 2 minus x over x. Open up the bracket. The 2 times with the x, 2x. And the negative we multiply in, we got x minus 2. So the answer of 1 over x squared, integration of this equivalent to x minus 2 over 2x. Are you okay? A little confusing in front, is it? Okay, I try to explain one more time, okay? Erase all first. I have fx equals to this. F prime x equals to this. F prime x basically is dy by dx. I'm supposed to find the integration. However, in the information given, I don't see integration symbol. You want to solve integration, your information must be in terms of integration. So how? So let's start with the differentiation. F prime x equals to negative 2 over x squared. And therefore, to find the f of x, I shall reverse the integration to the other side. Okay? The differentiation, when I reverse it to the other side, it will become integration. So this side will left with your y lah. So it's like this. Alright. Writing like this, are you okay? Okay, huh? If you cannot see this, then you shall let y be fx. You let dy dx be f prime x. If you are used to y and dy. So you set this one first. So this is another option. So you have dy dx equals to, the f prime x is negative 2 over x squared, and therefore y will equals to integrate negative 2 over x squared dx. Okay? And what is y? Y is fx. Fx is, so we know that integration of negative 2 over x squared dx equals to 2 minus x over x, right? This whole thing, you replace the fx value. Is that okay? Right. Once we have this, Now we need to find this one. Integration of 1 over x squared dx. Okay, so let's look at the information that we have. We have this. Use it. Let's use it. So integration of negative 2 over x squared dx. But they're not equal. They're not equal. How do I make it equal? I got an extra times negative 2, so I got to minus, add on the divide negative 2 in front. So now are they equal? The left hand side equals the right hand side. So this line, are you okay? Okay, therefore, negative 1 over 2, this whole thing, isn't it, is this? That's the reason I forced this one into my equation here, so that I can use the information that I have. So let's put it in. 2 minus x over x. Combine lah. Numerator with numerator, denominator with denominator. So 2x. The negative you multiply in, so negative 2 plus x, so positive put in front. So it looks nice. So integration of 1 over x squared dx is this. That's it. Is that okay? So unlike the previous question, after you integrate 8, you got the answer already. But this one, you have to do the adjustment. So always remember, my left hand side and right hand side must be equal, so that you will know what kind of adjustment that you need to do. Okay, let's see some more example. Okay, let's say this one. Given that fx is this, then your f prime x is this, then you got to find this. You try this. Mm-hmm.
Bottom right.
already, never mind. I know the front part is very confusing because I confused too. When I at your level, I am confused too. Do step by step, so don't worry. So Eugene, yours for this question? So
I think I might need to see how it actually went because I was quite confused also.
confused, huh? So we have fx, we have f prime x. F prime x is a dy dx. So if fx and f prime x to you is very confusing, you can change to y and dy dx. So this is sort of like y. And this one is sort of like dy dx. Okay, but the question wants the integration. So my information in hand is differentiation. So I have to make sure I change this into integration first so that easy to do the comparison. So I shall bring the differentiation over to the other side. So y equals to integrate 2 over x minus 2 squared dx. Okay, I got this. Now I can answer the question. The question is 1 over x minus 2 squared dx. But it's totally different from what I have in hand. What I have in hand was 2 over x minus 2 squared. Never mind, use it first. I got no choice already. I also have to use this. Now we think about the adjustment. How do I get back 1 over, you see the bottom is the same. How do I get back 1? Well, the 2 is extra, right? U times with 1 over 2. So that you can get back 1 over x minus 2 squared. So this line, are you okay? Alright, and therefore, isn't it this? I already know integration of this is y. And what is y? Y is x over x minus 2. So half times of x over x minus 2 multiply in. So we have x over, can you leave it as 2 bracket x minus 2? Can. If you want to open, also can. Right, this will be the answer. So the integration of 1 over x minus 2 squared dx equals to this. Try to have a habit in your final line, you complete your left hand side equals to the right hand side. Okay? Right? So that's it for the first concept. If the question gives you like this, then you don't have to find yourself. You just need to use existing information to find the answer. That's all. Okay? Now, so we have done with the concept of integration. Now let's learn how to integrate. Generally, indefinite integral. Okay, why do we call it indefinite integral? Indefinite, like it's never ending, you don't know. Basically, the graph is like this, yeah? Integration is the way that we find the, this is the curve, this is the y, this is the fx. If I integrate this fx, I'm actually looking the area under the graph. This is the original, sort of like the original application. I mean the main application of integration. So because you do not know where to start, where to stop, so basically you have indefinite integral. So you have a plus c there. Okay, let's look at the detail. Right. Like the differentiation is the reverse of differentiation. So integrate k, a constant, you got kx plus c. Always have a plus c there. If you have like this 4 dx, then the answer will be 4x. Original is 0. So 0 plus 1. So 4x power 1. No need to write. And then plus c. Okay, another one is if you see this. If you see this, what does that mean? It means there is an invisible 1 there. So the answer is just x plus c. So be careful. There's an invisible 1 there. Use other color so that you know that you must interpret this as integrate 1 dx yourself. So 1 means 1x, 1x. So you see, if differentiation, the D stand for downgrade your power, integration, I stand for increase your power. So from no x become, x power 0 become x power 1. Your differentiation always the power go down, isn't it? This one the always increase by 1. So from none to 1x, x power 1. Okay, simple, yeah? Next, this one. Generally, if you have x to the power n, well, increase the power by 1, divide the whole thing by the new power, and I always have a plus c there. Now, n can never be negative 1. N can never be negative 1. Example, integrate x to the power of 5 dx. So we got to increase the power by 1. So 6 divided by 6 plus c. Integration very easy. 6 over 6, 5 over 5, 3 over 3. As long as new power of always increase the power by 1 and divide by the new power. Okay? Now your n can never be negative 1. Yeah? What does that mean? I can also have this x to the power negative 3. X to the power negative 3 come from here. 1 over x to the power of 3. Now, mind you, integration only have 2 format that we can do. That is this one. I mean, generally ax to the power, and only these 2. When you see the x in the denominator, you have to bring it up. You need to bring it up to x to the power negative 3. Then only we can do. So what will we have? Copy exactly the same, plus 1 to the power, divide by the new power, that is negative 2, plus c. Simplify it. So we will have negative 1 over 2 of the x to the power negative 2. Never leave your answer in power negative 2. Always change it back to this one, to positive power. So this will be the answer. Is that okay? Alright? Now, what happened if x equals to negative 1? You've got to integrate this one. Okay, you have this. If you increase the power by 1, yeah? If you increase the power by 1, isn't you got 0? How can that be 0? That's why your n can never be negative 1. So the integration of 1 over x, this is IG level, ln x. Ln x. If I'm not mistaken. I forgot already. Okay, never mind, we'll come back to that. Okay, not in your syllabus. Your syllabus is only stop here. Only these 2. Okay, now make it more complicated. Add something in front. Add something in front, basically we go back to number 2, whereby the k I can just take out. Or you can think of like integration of 4x to the power of 3 dx. Well, you can just leave the 4 there, copy exactly the same 4x to the power of 3, increase the power by 1, divided by the new power, and then plus c. And this can be simplified. So the answer will be x to the power of 4 plus c. You can choose not to take out, it's fine. But the point is, we just focus, integrate, just like how we do for number 2. That's all. Okay? So you can just leave the 4 there, increase the power by 1, divide by the new power. Simple? Easy, right? Okay. Let's make something more complicated. Like this. If differentiation, we can separate each term, differentiate them separately. Integration, also the same thing. So I give you an example. Let's say you have 4x squared plus 5x minus 2 dx. Well, each and every term you can integrate separately. Copy exactly the same. Increase the power by 1 divided by the new power. Copy exactly the same. Increase the power by 1 divided by the new power. Copy this, 2x. Therefore, can we simplify? Yes. 4 over 3 x cubed plus 5x squared over 2 minus 2x. That's the answer already. That's the answer. Okay? Can? Any more complicated? Yes. The number 5. We have the substitution method. Another one is the formula. Okay? I introduce the formula first. Never mind, you copy this one first. I explain to you. It's the same thing. Okay, we go to the formula first. The formula is such that if you have ax plus b to the power of n dx, you do the same thing. Ax plus b, increase the power by 1, divided by the new power and divide by the coefficient for x. Why? Because integral is the reverse of differentiation. If in differentiation, isn't it, I bring this down to the front, do outside, then I got to follow by do inside, which means I got the ax. I differentiate, I got a. So the a and the a, n plus 1, n plus 1, so that you can get back ax plus b to the power of n. So you want to do the reverse. Initially in differentiation, you times a, so you got to divide the a also. You times the power, so you divide the power. So that is the reason we have the extra a there. Divide by a, because when we are in differentiation, we do inside, we got extra multiplication of a. So you will have to divide the a away. So this is by formula. So you got to remember. So for example, you may have the question like 3x plus 5. Now provided the rules is such that inside must be linear. It has to be linear. Cannot be 3x squared. This formula doesn't work. This formula is strictly for linear expression inside. That's why I say in your level, in this integration, you only have two kind of integration. One is this kind with the power outside. Another one is this kind. Only these two. You can only do these two. This one bring the power, increase the power by 1 divided by the new power plus c. This one increase the power by 1 divided by the new power, divide also by the coefficient for your x. Only this extra, and then plus c. So for this one, when you differentiate it, so you have 3x plus 5 raised up to the power 2 plus 1, which is 3, divided by the 3 and divided by the coefficient for your x, 3. So plus c. So the answer is 3x plus 5 raised up to the power of 3 over 9 plus c. See the power increase 1, right? Yeah, that's one of the way to check whether it's correct or not. Increase your power by 1. Another substitution method, this one is a little bit, okay, let me explain the substitution, but we don't use that, we don't use that. This is for extra knowledge only. So complicated, that's why we substitute it with u equals to kx plus b. And then after that, du by dx equals to just k. Du by dx is just k. So now my question is kx plus b raised up to the power of n dx. So now I need to substitute, the kx plus b, I already substitute with u. So u to the power of n. What about the dx? Well, I need to substitute the dx because my variable is u now, So this one I have to change to u. So what is the relationship between the dx and the du? Then from here, du is actually k times dx. So we replace the dx here is, sorry, what am I doing? Sorry. Okay, I want to replace the dx in terms of u. So dx go up, k come down. So du over k equals to dx. So whenever you see dx, you replace with du over k. The k can bring outside. So 1 over k integrate u to the power n with respect to du, isn't it? It's like the normal of this, isn't it? X to the power n dx, u to the power n du. Your variable is u. Then we just do like normal. Increase the power by 1, reduce by the new power, and then plus c. So isn't it this one, when we put back, it will be kx plus b raised up to the power of n plus 1 divided by k n plus 1 plus c. That's how we got this That's how we got this. Kx plus b to the power n plus 1 over n plus 1 times the k outside, because of this, because of the substitution. Is that okay? But we only use this, use this only. Right, so we stop here. Homework. think it's in the Google Classroom. Go to the Google Classroom. I think it's there. Yeah, let me see. Okay, integration already uploaded. Okay, integration. Oh, haven't. So I will add the practice intensive 3. So you do it. Okay. All right, that's all. Thank you very much. Chapter 3. Today is 6th of February. Practice intensive 3. Do only the integration questions. I mean the easy one that you already learned. Okay. Upload. Okay, that's all. Under here, EPH. Here, chapter 3. Okay. Are you able to identify which question to do? Yeah? You know, right? Which kind of question you can do, which kind of question you cannot do. Wait, let me check first. Let me check which one you can do. You can do 1, 2, 3. You can try 1, 2, 3. You can try. Oh, actually, you can try until question number 8. Okay, can try until question number 8. But the word problem, maybe you need to think a little bit. Cannot do, it's okay. If you can't do, it's okay. But yeah. Okay, try that one. Question 1 until 8. Alright, that's your homework for today. And also, the differentiation. Must continue to do, yeah? I'll wait for you to do so that you can ask me question. Because I cannot each and every question I try in the class. Cannot. You must try at home, then bring up the whatever question that you don't know, then we can discuss in the class. Including your schoolwork, if you have problem solving the textbook question, you can ask in the class. Okay, thank you very much. You can go now. Alright, so you need to stay for the IG question. Okay. Yijing, you remember to send me your work, Eugene also. Okay, thank you.
Alright, thanks teacher. Good night.
Good night.